Okay, so I'll do 6, 7, 8, 12, and 13 together in one video. For a more thorough run through of this topic, which is hypothesis testing, look at the video for number 14. That'll give you a stronger idea. All right, so for all of these problems, it's a specific type of thing we're being asked. So a test of h sub 0 mu equals 69. That's our null hypothesis. The null hypothesis is that the mean is actually 69. The population mean is actually 69. The alternative hypothesis, H1, or in some cases you'll see it written as H sub A, is that the population mean is actually less than 69. So null is that the mean is actually 69. Alternative is that the mean is less than 69. And we perform that test using a significance level of alpha equals 0.05. And they give us the value of the test statistic. So first, let's determine if we should reject this null hypothesis or not reject this null hypothesis, given this information we have here. Okay, so the first thing I want to do is I want to look at this alpha level of 0.05 and determine what the critical value for that 0.05 is, the z critical value. So I'm going to go to my table, because remember the table gives us the area to the left, and this is a left tail test because this is saying that the mean is less than 69. Right? The alternative hypothesis says that the mean is less than 69. So what I'm kind of testing to see I'm testing down here. This is my critical region, right? This is my 0.05. And if my mean is actually down here, then I will say, yes, there's a critical difference. The mean is less than 69, and I should reject that null hypothesis. Right? If my mean turns out to be down here, then I will say, okay, the null hypothesis, I'm going to get rid of that because the data supports the fact that the mean is less than 69. I'm not sure the mean is less than 69, but my data supports that fact, supports that idea, that hypothesis, I should say. All right. So to determine what this z value is, this z value here, this critical value here is, that's why I go to the table to determine what z value gives me this 0.05 here. So let's go to the table, 0.05, 0.05, 0.05. We've seen that number before. 0.05. Right here. 0.05. Negative 1.645 is the one that I use. So that z critical value, I'll say z crit, is negative 1.645. That's this value here, right? That's this value here. So maybe I'll erase this and write negative 1.645 here. Negative 1.645. Now here's what we're testing. If this test value is in this region, that means I reject the null hypothesis. That means that the data supports that the mean is less than 69. Right? So if this value is less than negative 1.645, I reject the null hypothesis. If it's not, if it's somewhere over here, then I don't reject the null hypothesis. Could still be less than 69, but I don't have the data to support it. So either I reject the null or I don't reject the null. So this negative 1.54, it's not less than 1.645, it's greater. It's in this region here. Right? So 1.5, negative 1.54 is somewhere here. So the decision here is do not reject the null. That's the decision. We do not reject the null hypothesis. So this is the decision based on the hypothesis test. Now, we get some more information. The true value of the mean is actually 69. The true value of the mean is 69. Now, did we make the right decision, or did we make a type 1 error or a type 2 error? Okay, simple little table here I'm going to make. 2 columns, 2 rows. So the first HO is true. The null hypothesis is true, or the null hypothesis is false. And then here we reject H sub 0. Do not reject H sub 0. So what I'm checking to see is which situation we fall into. Now, we did not reject the null, so we're here. We're here. We did not reject the null. We're here. Now we have to check to see if the null is true, if the null was true or false. So the true value of the mean is 69. That was exactly our null. So the null hypothesis is true. Now here's the way this works. If the null hypothesis was true and you rejected, that means you made a mistake. If the null hypothesis was true and you rejected it, then you made a type 1 error. If the null hypothesis was false and you didn't reject it, you made a mistake. That's a type 2 error. Otherwise, you made the correct decision. So in our case, the null hypothesis was true. It matches that. And we did not reject the null hypothesis, so we made the correct decision. If the null hypothesis was true and we rejected it, then we would have made a type 1 error. If the null hypothesis was false and we didn't reject it, then we would have made a type 2 error. That's the analysis we're doing for every one of these problems. First, determine if we accept or reject. Then we see if we made a type 1 error or a type 2 error. Pretty straightforward process. Let's try again. Null here for number 7 is the mean is 48. Alternative is the mean is less than 48. Another left tail test. Another less than, another left tail test. Another one of these. Significance level of 0.05 again. So I already know my Z critical value is negative 1.645. Yes? So based on this, so this is negative 1.645. Negative 1.46 is greater than that, not in the critical region. So again, I do not reject the null. I only reject the null if my test value is in this critical region. Okay? So I'm going to draw this table. Do I need to draw this table again? Yeah, let's draw it again. The bane of my existence, drawing tables. So HO true, HO false, reject, HO. It's hard to write small on this thing. Do not reject. I mean, my handwriting isn't beautiful, but, you know. So here's a type 1 error, type 2 error. Here you're correct, here you're correct. So let's see what the mean actually is. The true value of the mean is 45. That's less than 48. So the null hypothesis was false. The null hypothesis was false. We did not reject it. So we actually made a type 2 error here. Okay, the null hypothesis was false because the mean is less than 48. Mean does not equal 48, so the null hypothesis was false. This is the real deal. These were our hypotheses. This is what really happened. So the null hypothesis is actually false. And what we decided to do was not reject it. So we made a mistake. Okay. Excuse me. Oh, I shouldn't have done number 8 in here because that's a p-value one. So I'm gonna skip number 8. Number 8 I'll do in another video because that's p-value. I didn't mean to do that in here. So just throw that up. Number 12 though is one that we want. Okay, so 12 and 13 we want those two. Okay, so 12 null hypothesis is 58. Alternative hypothesis is the mean does not equal 58. It's different from 58. This is an example of a two-tailed test. It could be different above or different below. Could be greater than or less than. Just different from 58. So this is a two-tailed test. This is going to be, I don't know why that happened. This is going to be like the alpha over 2 we use for the confidence intervals. So if this critical region adds up to 0.05, then each of these is 0.0025. No, 0.025. Sorry. Each of these is 0.025. Now I go to the table to get that. 0.025. We saw that before. Negative 1.96, positive 1.96. Those are our values. Negative 1.96, positive 1.96. Same analysis though. If that test statistic falls in either of these two values, in either of these two critical regions, we reject the null hypothesis. Negative 2.14, negative 2.14, negative 2.14 is here in the critical region. So reject the null hypothesis. Negative 2.14 is like here, right? Thinking about a number line. Negative 2.14 is here. In the critical region, reject the null hypothesis. So, draw my table again. H sub O is true. H sub O is false. Reject, null, do not reject, null. And this is a type 1 error, type 2 error. This is correct, this is correct, right? So in real life, in the true value of everything, the true value of the population mean is 58, which matches the null. So the null hypothesis in this case is true. The null hypothesis is true. The mean is 58. And what we did is we rejected the null. Null hypothesis was true. The mean is 58, and we rejected it. We made an error of type 1. So 13, we're doing the same thing. I dropped my pen on the floor. 13, we're doing the same thing. A test of the null hypothesis, the population mean is 65. Versus the alternative hypothesis, the mean is different from 65. Another two-tailed test, right? Oh, green. So the mean is different from 65. And we're using a significance level of 0.01. So in each of these regions, I have 0.005, right? Half of that. Okay, so I want to check the table for 0.005. 0.005. We use negative 2.58 for that. So on the left is negative 2.58. On the right is positive 2.58. So let's determine if we reject or do not reject the null hypothesis. Given this, the test statistic is negative 2.68, which is definitely in that region. Negative 2.58 is my z-value here. That z-critical value, the z-test value, is negative 2.68, which is in this region. So because of that, I will reject the null, reject H sub 0. Let's make a little table here, see what actually happened. HO could be true or false. Yeah, you reject HO. Do not reject HO. I didn't say accept HO, right? But do not reject it. Type 1 error, type 2 error. Here you're correct. Here you're correct. Okay, let's test it. Let's check this out. So in real, the true value of the mean is 69, which is different from 65, which is different from 65. This is not what the null hypothesis is saying, so the null hypothesis is false. And we did reject the null hypothesis, so we made the correct decision here. That's these.